All right, Algebra 1 students, let's look at Unit 2, Lesson 13, Solving Systems by Substitution. So our lesson goals are, I can solve systems of equations by substituting a variable or an expression. So essentially what that's saying is, we can solve these by taking an expression and plugging it in into another equation to do a little bit of math with it. I know more than one way to perform substitution and can decide which way or what to substitute based on what the given equations are written, or based on how the given equations are written. So based off of how the equations are written, we may have a better way of doing the substitution than another way. So we need to have a couple options to us. All right, so our old vocabulary of solution to a system of equations, essentially where two equations intersect or they share. Systems of equations are two or more equations that are utilized in the same situation. And our new word is substitution, replacing a variable with an expression it is equal to. So I have two examples of what this could look like. Our first one is a really simple one with a number replacing a variable. So if I had 2x plus 3y equals 7 and I knew x equaled 6, I could substitute the 6 in for the x and create 2 times 6 plus 3y equals 7. This is a much simpler problem to solve. Here's another situation where I am putting an expression in for a variable. So I have 2x plus 3y equals 7 again, but here I have x equaling y plus 1. So I can plug y plus 1 in for x. Now when you plug in an expression, a lot of times you'll have to use parentheses around it. So you create 2 times y plus 1 plus 3y equals 7. Distributing would help here, but it's still a simpler problem to solve than the original two problems. All right, so for your warm-up, we're going to look at a system or a graph of systems, and you need to pick out which system you think could be shown here and explain why. So determine if each of the systems could be represented by the graphs and explain how you know. So our first system is x plus 2y equals 8 and x equals -5. Could this be represented up there? Explain how you know. Y equals -7x plus 13 and y equals -1. Could this system be represented by what you see? 3x equals 8. 3x plus y equals 15. Could this system be represented up here? And then our last one is y equals 2x minus 7. 4 plus y equals 12. Could this system be represented up here? One of the four works, the other three don't. Please figure out which one that is and kind of explain how you figured it out and how you know. Bring that to class tomorrow. That will start our discussion. Thank you.